This is SpaceTime, Series 21, Episode 69. Coming up on SpaceTime, water confirmed on the lunar surface, hints of new mysteries in neutron stars, and the new Vega-C to begin flying next year. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have directly observed water on the lunar surface for the first time. The water was identified as frozen ice in the darkest and coldest parts of the moon's polar regions. The ice deposits, which are thought to be ancient, were also distributed in a very patchy fashion. At the South Pole, most of the ice was concentrated in lunar craters, while at the moon's North Pole it was more widely distributed but more sparsely spread. The study's lead author, Shoa Lai, from Hawaii's Institute of Geophysics and Planetology, says the lunar water ice was extremely patchy, very different from other planetary bodies, such as Mercury and Ceres, where the ice is relatively pure and abundant. A spectral analysis suggests that the ice patches were formed by slow condensation from a vapor phase, either due to impact or water migration from space. Scientists used NASA's Moon Mineralogy Mapper instrument aboard India's Chandrayaan-1 spacecraft to identify 3 specific signatures which definitely proved that the water ice was on the surface of the moon. It collected data which not only picked up the reflective properties expected from ice, but was also able to measure the distinctive way its molecules absorb infrared light, so it could differentiate between liquid water, vapor and solid ice. Most of the newfound water ice lies in the shadows on the floors of craters near the poles, where the warmest temperatures never climb above minus 160 degrees Celsius. Because of the very small tilt of the moon's rotational axis, sunlight never reaches the bottom of these regions. Previous observations had indirectly found possible signs of surface ice at the lunar South Pole, but these could have been explained by other phenomena, such as unusually reflective lunar soil. Constituents of water, known as hydroxyls, have also been previously identified in the lunar soil. The discovery is important because with enough ice sitting on the surface within the top few centimetres, water could be accessible as a resource for future expeditions to explore and even stay on the moon, and potentially far easier to access than water detected deep beneath the lunar surface. Learning more about lunar water ice, how it got there, and how it interacts with the larger lunar environment will all be part of a key focus for NASA as America moves towards a return to the moon. The Chandrayaan-1 spacecraft was launched aboard an Indian space research organisation PSLV Polar Satellite Launch Vehicle from the Satish Dhawan Space Centre on the Bay of Bengal coast back on October the 22nd, 2008. The 1,380-kilogram spacecraft included an orbiter and an impactor designed to search for water on the moon. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
The first direct evidence of water ice on the moon. I suppose we should start by talking about the fact that other forms of ice exist in the universe, and we've certainly found evidence of that.
That's right, yes. Ice, we tend to use the word ice for anything that's liquid at the kind of temperatures that we deal with, and is not liquid at the temperatures that we often find. And I guess the commonest is dry ice, which of course is solid carbon dioxide, and that's found around the poles of Mars. But what we're talking about now is definitely water ice, good old H2O, but at a temperature below zero. And this story goes back actually to the early 1960s, believe it or not, when people speculated that, because by then we knew that some of the craters on the moon near its north and south poles, because they never ever see sunlight. And so in the bottom of the craters, the speculation was that we might find all kinds of interesting things there. And one of them was that water ice might exist in these permanently shaded areas. Moving on a few decades, there have been detections of a kind of smoking gun for ice, if I can mix all the metaphors,
Sure.
by spacecraft like NASA's Lunar Reconnaissance Orbiter and the Indian orbiter Chandrayaan-1, which did an amazing job at detecting hydrogen above the north and south poles of the moon. So both of those spacecraft have picked up hydrogen in the sort of I was going to call it a rarefied atmosphere, but even that's gracing it with too strong a term. It's just a few atoms that basically leak up from the surface of the moon. But hydrogen is amongst them. And hydrogen is what you expect if you have a body of either water or frozen water, in other words, ice.
Yep.
So the interpretation has always been that that was, as I said, a smoking gun for ice. But there are other possibilities there. And there is a scientist, Dr. Shuai Li, who's at the University of Hawaii. He has made the comment that, yes, it could be just hydrogen that's coming up from the moon. It could be hydroxyl, which is another molecule that has oxygen and hydrogen in it. Or it could be water, or it could be anything else with hydrogen. What he says is the early data could not distinguish which is which. And so what he has done, he and his team of colleagues in the University of Hawaii and elsewhere, they've used an analysis of data from an instrument called the Moon Mineralogy Mapper, which was also on the Chandrayaan-1 spacecraft. And it essentially looks at the spectra. You know, it measures the rainbow spectrum of the surface that it's flying over. Mm-hmm. But it does that in the infrared. That's the redder than red region of the spectrum, invisible to our eyes. And so they've done a very careful analysis of the data that you get when you fly over the north and south poles of the moon. And sure enough, they have identified the signature, the fingerprint, if I can once again mix metaphors, the fingerprint of water ice. So this is definitely water ice. It's got a characteristic spectral signature, which they've detected in many, many spots above both the north and the south pole of the moon. It turns out, actually, that there's more of it down in the south. There are larger areas of water ice in the southern polar region, and that's probably because the craters are deeper there. So you've got.
I thought it was because that was the bottom of the moon, and that's just naturally where water would drain.
Yes,
someone would believe that if you really tried to convince them.
Yeah. No, look, it's only the bottom of the moon seen from our, northern-centric view of the universe. If you're standing there, it's the top of the moon, I can tell you. So, yes, it's like, it's just spots of water ice, but there are more of them in the south than in the north.
Now, this is a pretty important discovery because water ice means potential for, maybe habitation, but it also means that making fuel becomes a real thing.
Exactly, that's right.
And they are talking about going back to the moon. And there was an article this week that argued that we should be focusing more on the moon now than Mars, and raising all sorts of reasons why, which I won't go into. But there's definitely plans to go back to the moon. China's definitely keen to get there.
Yeah, actually, indeed. And other countries as well. The Indians have got their sights on the moon as well, and they've done such a fantastic job with Chandrayaan-1. It's been a very successful project. But yeah, what you've said is absolutely right. If you can find stores of water on an alien world, then it absolves you from having to really worry too much about finding fuel, because if you can put solar panels there and dissociate the water into hydrogen and oxygen, what you've got is rocket fuel.
Yeah, which is very handy stuff when you want to get off something and get back to Earth.
Yeah.
The other interesting thing is it's pretty inhospitable terrain, that part of the moon. It's I believe, if not the coldest place in the solar system, very close to being the coldest place in the solar system.
It's very, very cold, that's right. The figure I've got is minus 238 degrees Celsius.
And for you Americans, that's minus several million degrees.
Fahrenheit. It's very cold. I think, actually, I have a feeling Pluto is minus 239. I can't remember. Yeah. It's very cold out there in the dim and distant bits of the solar system.
So what happens now that they've confirmed beyond reasonable doubt that there's water ice on the moon? Everyone just goes, "You ripper," clanks their glasses together and gets on with it.
Yeah, look, it's just additional knowledge. I mean, one of the interesting things that we see from this, though, is that it's rather different from ice deposits that we know are elsewhere at the northern and southern poles, and they are on the planet Mercury, and that's even more weird because Mercury is so close to the sun, but it does have ice deposits near its northern and southern poles. And Ceres, the dwarf planet Ceres, which is out there in the asteroid belt, a very interesting world for all kinds of reasons. It's still, I think, being orbited by the Dawn spacecraft, a NASA spacecraft. But they have kind of much larger areas of ice rather than just these spots of ice that have been found on the moon, and that raises questions itself. So there will be more research done on this to find out why the ice is patchy rather than these contiguous areas.
Probably just mixed up with the soil or something like
That's
that.
a possibility, yeah.
It also opens the door to the probability that water ice is more abundant in the universe than we probably have ever considered.
I think that's a lesson that we've already learned, Andrew, because we see it everywhere. Compared with even only 10 years ago, if somebody had said, well, you know, these are moons of Jupiter and Saturn, a lot of it is ice, and then there's a lot of water there as well. In fact, there's more water on Titan and I think Europa, it might be, one of the moons of Jupiter, more liquid water than there is in all the oceans of the Earth. So we're realizing just how abundant it is. It's not really a surprise because the radio astronomers have been telling us for years, for decades, that the most common two-element molecule in the universe is water, because you can pick it up as a vapor by telescopes, just in interstellar space, in nebulae and things like that. Water is everywhere.
And it sort of brings back into play that four-letter word we occasionally bring up, which is life. The L word, where there is liquid water, there may well be life. So
there may well be, but that's a lesson that we have yet to confirm.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. A new study claims that protons play a far more significant role in the characteristics of neutron stars than previously thought. The findings, reported in the journal Nature, have implications for how heavy elements such as gold, platinum and uranium are made. Neutron stars are created when some of the most massive stars in the universe, these are stars far larger than the Sun, reach the ends of their lives and explode in powerful events known as core collapse supernovae. These explosions are bright enough to briefly outshine an entire galaxy. What's left behind is a highly compacted superdense stellar corpse, in which the positively charged protons and the negatively charged electrons have all been crushed together to form neutrons, hence the star's name. Although only a dozen or so kilometres wide, neutron stars are the densest objects in the known universe, other than black holes. The new research suggests that some properties of neutron stars may be influenced not by their multitude of densely packed neutrons, but also by the substantially much smaller population of protons. Protons make up just 5% of a neutron star's mass. And this is where it gets interesting. Because protons carry substantially more energy than previously thought, they may contribute to the properties of a neutron star, such as its stiffness, its ratio of mass to size, and even the way it cools. One of the study's authors, Professor Orhen from the Massachusetts Institute of Technology, MIT, says the findings could shake up science's current understanding of how neutron stars behave. Hen and colleagues are arguing that even though neutron stars have these neutron-rich nuclei, the protons are moving faster than the neutrons, and so are responsible for determining significant properties within the star. The study's co-author, Professor Eli Pazetsky from the Tel Aviv University School of Physics, says the cosmological abundance of nuclei isn't well understood. And that's important because scientists think the merging of two neutron stars is one of the main processes in the universe which creates nuclei heavier than iron, things like gold, platinum and uranium. After studying neutron-rich nuclei on Earth, the authors extrapolated their findings, reconsidering the role played by the small fraction of protons within neutron stars, and the impact that has on the nuclei creation process. The authors were looking for signs of proton and neutron pairs in carbon, aluminium, iron and lead nuclei, each with a progressively higher ratio of neutrons to protons. They found that as the relative numbers of neutrons in an atom increased, so too did the probability of a proton forming an energetic pair. The likelihood that a neutron would pair up, however, stayed about the same. Pazetsky says this trend suggests that in objects with high neutron density, the minority protons carry a disproportionately large part of the average energy. The research was based on data collected by the Continuous Electron Beam Accelerator Facility at the Thomas Jefferson Laboratory in Virginia. The authors examined data from a 2004 experiment in which electrons were used to bombard carbon, iron and lead nuclei, with the goal of observing how particles produced in nuclear interactions travel through each nuclei's respectively larger volume. See, along with their varying sizes, each of the 4 nuclei has a different ratio of neutrons to protons, with carbon having the fewest neutrons and lead the most. The group studied the data looking for signs of high-energy protons and neutrons, indications that the particles had paired up, and whether the probability of this pairing changed as the ratio of neutrons to protons increased. Another study co-author, Professor Larry Weinstein from Old Dominion University, says people were using the detector looking for specific interactions, but of course it also measured a bunch of other stuff, other reactions that took place at the same time, and that allowed Weinstein and colleagues to see if there was anything else interesting going on. Eventually, they observed that as the number of neutrons in the atom's nucleus increased, the probability of protons having high energies, and therefore having paired up with a neutron, also increased significantly, while at the same time the probability of neutrons having these high energies remained the same. You're listening to Space Time. I'm Stuart Gary. Scientists have successfully measured the force photons exert on matter. The breakthrough, reported in the journal Nature Communications, finally confirms Johannes Kepler's original 1619 prediction. See, Kepler noticed that no matter which way a comet's moving, its tail was always pointing away from the sun, and he speculated it was light pressure from the sun which was keeping the tails of comets always pointing away. James Clerk Maxwell then further expanded on this idea in 1873 when he proposed that momentum within electromagnetic fields accounted for the phenomenon. However, we've had to wait until now for the technology to actually test the hypothesis and physically measure the minute interactions between photons and matter to be developed. One of the study's authors, Professor Kenneth Chow from the University of British Columbia, says until now scientists hadn't determined how this momentum was converted into a force or movement. To resolve the issue, Chow and colleagues fired laser pulses at a special mirror fitted with acoustic sensors and wrapped in a shield to minimize interference and background noise. Although they couldn't measure the photons directly, the authors were able to measure the effect of the elastic waves rippling across the mirror by tracing the features of the waves back to the momentum of the light pulse itself. This is Space Time. I'm Stuart Gary. With just a year to go before Vega-C lifts off from Europe's spaceport in French Guiana, preparations for Europe's next launcher are gaining momentum. The introduction of the new Vega-C will result in an increase in performance for Vega's current launcher, allowing it to increase payloads from 1,500 to 2,200 kilos with no corresponding increase in launch costs for a 700-kilometre height polar orbit. The key to this increased performance will be the new P-120C solid-fueled rocket first stage. The same rocket will be used to strap on solid rocket boosters for the new Ariane 6 launcher, destined to replace the current Ariane 5 in 2020. The P-120C's first hot static firing test will take place shortly at Kourou. Developed by Euro Propulsion under contract to Avio and the Ariane Group, the P-120C is 13.5 metres long and 3.4 metres in diameter, making it the largest solid propellant rocket engine ever built in one segment. The Vega-C's upper stage will be powered by a 2.45 kN liquid-fueled Zafiro 40 vacuum engine. The Zafiro 40, also developed and manufactured by Avio, was static-fired in early March on the island of Sardinia. The new Vega-C's upper stage has had its liquid fuel capacity increased by about 150 kilograms, and the structure itself has been optimized using carbon composite sandwich panels. The new upper stage will help improve the overall flexibility of the Vega-C, allowing the new launcher to deploy more than one payload on a mission. A private Israeli company has announced plans to try and become the fourth nation on Earth to land a spacecraft on the Moon. SpaceIL says it will launch its lunar probe aboard a SpaceX flight in December with an expected lunar surface arrival date of February the 13th, 2019. So far, only the United States, Russia and China have landed spacecraft on the Moon. Built by Israel Aerospace Industries, the 2-metre-wide, 585-kilogram lander is equipped with science packages to study the Moon's magnetic field. The $95 million spacecraft will be transferred to the United States for spaceflight payload integration in November. Its December launch will place the spacecraft into a 60,000-kilometre high lunar transfer orbit, from where it will gradually increase the elongation of its elliptical orbit. Although far slower than simply flying directly to the Moon, which takes about 3 days for lunar orbital insertion, the manoeuvre saves on fuel and consequently reduces launch weight, meaning more of the mass budget can be used for scientific payloads. It looks like one of the implications of the United Kingdom leaving the European Union following the Brexit vote is that Britain will have reduced access to Europeans' Galileo satellite navigation system, getting the run-of-the-mill civilian access that anyone can have rather than a more precise military level of access needed for pinpoint weapons accuracy. The $16 billion Galileo project was designed to give the Europeans independent satellite navigation access rather than relying on the American Global Positioning Satellite System GPS. Like GPS, there are restricted access elements of Galileo which the UK military has access to at the moment, but which it will lose as Brexit takes hold over the next 2 years. One option for the UK involves even closer ties with the Americans for GPS access. But there are also rumours of the possible development of an independent British system, possibly with Australia as a partner, or as part of an enhanced Five Eyes intelligence sharing alliance with Australia, New Zealand, the UK and Canada. Five Eyes is best known for its Echelon signals intelligence surveillance system. Echelon and Transient are the two halves of an umbrella program called Frosting, initially established by the NSA and CIA during the Cold War to spy on the military and diplomatic communications of the Soviet Union and the Communist Eastern Bloc. China has launched a new high-resolution Earth observation satellite aboard a Long March 4B rocket. The mission blasted off from the Taiyuan Satellite Launch Center in northern Jiangxi province, placing the spacecraft into an elongated 691 by 245 kilometre high orbit. Beijing says the new satellite, known as the Gofang 11, will be used for land survey, urban planning, road network design, agriculture and disaster relief operations. The flight was the 22nd orbital launch by China this year and the 282nd launch of a Long March series rocket. I'm Stuart Gary. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has found that exposure to secondhand smoke in childhood could increase the risk of developing arthritis as an adult. The findings, reported in the journal Rheumatology, are based on examinations of 100,000 French female volunteers, showing a strong association between smoking and an increased risk of arthritis. But more surprisingly, the study also found that non-smokers who suffered passive exposure to tobacco during childhood also suffered an increased risk of arthritis, the magnitude of the increase being similar to that associated with regular adulthood smoking of around 40%. A new study warns that marine heat waves, just like the one which bleached much of the Great Barrier Reef in 2016, are set to become far more common, more extensive and more intense as a direct result of global warming. The findings, reported in the journal Nature, showed that the number of marine heatwave days doubled between 1982 and 2016, and this is projected to increase further as global temperatures continue to rise. Scientists found the likelihood of marine heatwaves occurring is 41 times higher if temperatures rise by 3.5 degrees as predicted under current emissions policies. New research has identified more than 36 genetic regions linked to women living longer. The findings, reported in the Journal of the American Medical Association, also identified 46 separate genetic regions specific to men. The authors say this highlights that sex differences in the genetics of longevity are remarkable and have been overlooked in previous studies. They say further work on how these genes interact with the environment could help target more individualised healthcare for elderly men and women. A new study has found that prehistoric Egyptians were using embalming to mummify their dead far earlier and across a far wider geographical area than was previously thought. The findings, reported in the Journal of Archaeological Science, represent the first time that extensive tests have been carried out on an intact prehistoric mummy. The evidence reinforces previous findings that embalming was taking place at least 1,500 years earlier than previously accepted. Forensic tests on the prehistoric mummy, originally thought to have been naturally preserved from being buried in hot dry sand, reveal an embalming recipe remarkably similar to what was employed at the peak of Egyptian mummification some 2,500 years later, and may in fact be showing scientists where classical mummification actually originated from. The scientific method involves observation, hypothesis, experimentation, analysis, and conclusion. Science, you see, is all about critical thinking. It's a search for the truth. Don't just take someone's word for it. Test the claim. See if it's factual and stands up, or if it's just a great steaming pile of woo. You see, that's what skepticism and evidence-based science is all about. It's a search for the truth. And remember, scientific facts don't care if you believe them or not. A Canadian tribunal has now ruled that there's no proof that a British Columbia boy's migraines are caused by Wi-Fi. The president of Australian Skeptics, Aran Segev, has the details.
This is a teenage boy whose mother and grandmother claimed that he had migraines and other medical effects due to the Wi-Fi radiation at school, and they wanted the school to provide a Wi-Fi free environment for him. Despite the lack of evidence for any such link, the school actually went to extraordinary lengths to support the boy. They gave him a room where he could be during lunch away from the other boys with their mobile phones. They actually allocated about 25% of the school to be Wi-Fi free. But surprisingly, or unsurprisingly, the problems did not go away. Rather than come to the correct conclusion, which is that there is no link, the family concluded that not enough was being done. The ruling by the British Columbia Human Rights Tribunal, which has ruled that there was no evidence to support the claims. And unfortunately, the boy has now been pulled out of standard education. So the family clearly does not accept this ruling, and they do not accept the evidence. And the boy now studies remotely. And it is reported that he now has very limited social interaction because of this. And obviously, that's a very sad ending to the situation. Well, perhaps not an ending, because this boy will probably have to live with this kind of belief for at least some time. And anybody who's watched the TV series Better Call Saul will know that the effects of the fake EMF sensitivity can be quite detrimental to somebody's life.
And that report by Aran Segev, president of Australian Skeptics. You're listening to SpaceTime. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from SpaceTimeWithStuartGary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.